So in the previous video, we talked about why you would add positional embeddings to this token embeddings. Well, now we have input to the encoder because this becomes an input to the encoder. And you might ask, what is an encoder? So in this model, there are things known as encoder and decoder. And like I said, we have just prepared input to the encoder. We need to prepare an input to the decoder as well. But while I was trying to do that, I noticed some fix I needed to do for my dataset. I was preparing my dataset for decoder incorrectly, and along the way I did some optimizations, refactorization, so I'd like to talk about it in today's video. So if we look at some code from the past in my GitHub, I called this load daily dialog function 3 times, whereas now I only call it once. So yeah, it just makes my code faster. And why didn't I do this earlier? So the dataset looks like this, and I needed to separate them separate this into input and targets, which looks like these. These are inputs and targets. So I used these 3 data sets. That's why I needed to call this many times. So I could have just, now I'm just using this dataset only, but for some reason I used Python to split this dataset into inputs and targets and load them all. Yeah, because now I'm splitting this dataset into input and targets in C++, but yeah, like I said, I used dataset. I used Python to just prepare the dataset and saved in this dataset folder and just call this C++ function and loaded them. And also, the reason you might ask, why wouldn't you just load input and targets, not loading input and target? So I need to also load the original dataset because it includes both inputs and targets prompts. So in inputs dataset, some of the prompts are missing that are in targets prompts. Same for targets, some prompts are missing that are in inputs. But because this dataset is the original dataset that used to create these inputs and targets, it includes all the prompts. So if I utilize this to create vocabulary, it would include all the possible words used in this data set. Although I could have just used either of them, even though some of the prompts are missing. But yeah, maybe I was aiming for perfectionism. Yes, so that was that. And So this function looks like this. I precompile characters I replace using regex, because if I had these inside this while loop, maybe makes my function slightly slower. And so I said for encoder and decoder, I need inputs for individual components, but there are also another dataset I need to prepare, which is like, for traditional models, you have input and targets, or these targets are called Y values or labels. Similar to that, this decoder needs inputs and outputs. So this is an input to this is an input to encoder, and this is input to decoder, but this is Y or label for decoder. So I return these three tensors, data sets from this function, load data dialog, and the data set looks like this. So this is the first lines are inputs for encoder, and second lines are inputs for decoder. So for inputs for decoder, it's not you don't need to have it all the time, but it's better to have start or sentence tag. And also for the input for the decoder, the sentence are shifted right, whereas output for the decoder are shifted left. So as you can see, this one are missing SOS, and this one is missing EOS at the end, because they are both shifted right and left. And the last lines are used for vocabulary. So this is what I've been talking about, that for dataset used for making vocabulary, I needed to have them. Because I wanted them to include all the words as possible. So they would include both SOS and EOS, and never missing any prompts. So that's an optimizations and refactorizations for this loading dataset function. And next so this is also an optimization. I was calling this text vectorization function twice, whereas, so if I do that, I was making vocabulary twice, even though in a standard, or like it's not, it's pretty common to only make vocabulary once. So I changed the function to first of all, this function was just purely a function, but now I made it, I changed to a class, so that when instantiating this class, I just pass vocabulary size and sequence length, and after that I used member function called build vocab, which obviously makes vocabulary from these datasets. So here I add SRS and EOS tag to this source dataset. So I transformed the input for encoder to include SOS and EOS, but in general, you'd make vocabulary out of wiki or common crawl, open web text, and sometimes, but not sometimes, but research papers from archive. And also there are pre-trained ones as well. So yeah, for the future I might use this method. So after I made a vocabulary, I vectorize or transform these sentences into unique IDs using this vectorize function. So which is this one. So before, these all codes were in one function, but now I separated into two functions where one of them makes vocabulary and the other one uses that vocabulary to make unique vectors. So that's, yes, so now I just make vocabulary once, and yeah, after I did that, I prepared input for encoder and decoder and output for decoder. So now the train function takes not only X and Y like I used to do that. So in train function I used to take only X and Y, but in this model it would take X1, I mean, yeah, just these three types of data sets. And similar to what I did for encoder, I do for decoder. I embed input for decoder and also add positional embeddings to that embeddings and pass that to decoder. Although I'm not really sure, I need to do some research that if I need to have separate embedding layer and positional encoding layer to encode this inputs for target. because I just use same embedding layer and positional encoding used for inputs for encoding, so encoder. So but anyways, I think this is it for today's video, and maybe for next video I really like to talk about encoder, because even though now I started to understanding the functionality of encoder, but not exactly. So yeah, so this is it for today's video. Thanks for sticking to the end of the video, and thanks for all the supports. Okay, thanks.